Okay, girls, we're going to finish topic 3, the unit circle, via this podcast so that we can wrap this section up. So we talked about when you end up rotating and landing on one of the quadrantal angles that you just think of your definition of a unit circle, which means radius of 1. And so you get the 4 following ordered pairs, okay? So these are some of the easiest questions in terms of finding the trig values of the trig functions at the quadrantal angles, but I do want to go through an example. So if we look at the next example, find the 6 trig functions for easy values of t, and it says say t equals pi radians. So that means we would rotate to pi radians, and that would put us at this point on the unit circle, which has the ordered pair -1, 0. And so if we want to find the sine of pi radians, we know sine is the y value, so it would equal 0. Cosine of pi radians, cosine is the x value, so that would equal -1. And then tangent is y over x, or 0 over -1, which equals 0. Here's the tricky part. Not that it's really that tricky, but if we want to then find cosecant, secant, and cotangent of pi radians, remember those are our reciprocal trig functions, we would just take the reciprocal of 0. And that's where I see students have a lot of issues. If you think of any fraction any number can be written as a fraction if you just put the numerator over 1. So if you think of 0 as 0 over 1, the reciprocal would be 1 over 0. And the same thing would happen for cotangent. We would get 1 over 0. Well, 1 over 0 is undefined. You cannot divide by 0. So therefore, the cosecant of pi and the cotangent of pi would both be undefined. And then secant of pi is pretty easy because the reciprocal of -1 would just be -1. So be careful on the trig functions for the quadrantal angles. You'll probably get some values where the answer is undefined. All right, moving on. If you know the value of sine, cosine, and tangent in quadrant 1, you can find that, the value of those 3 trig functions for any angle in any quadrant. You just have to find the reference angle. Okay, remember the reference angle is the acute angle formed by the terminal side of the angle and the x-axis. Always go back to the horizontal axis. Okay, so our next example here will kind of illustrate that. If I want to find the sine, cosine, and tangent of 315 degrees, here's 315 degrees. Well, my reference angle is going to be 45 degrees then. And I know the sine of a 45-degree angle is rad 2 over 2, but I have to remember that I am in the 4th quadrant, and any point on the unit circle in the 4th quadrant is going to have a negative y value. So that would be the ordered pair. So sine of 315 would be negative rad 2 over 2. Cosine would be positive because the x value is positive in the 4th quadrant. And then tangent, if I do y over x, or sine over cosine, would be -1. Okay, so you find the reference angle, but then it's really important to figure out where your angle measure is in terms of the quadrants. And I showed some of you this, and a lot of you remembered this from Algebra 2, this acronym, All Students Take Calculus. Okay, it tells you which trig functions are positive in what quadrants. So you start in quadrant 1 with the A, and that means all 3 of these are positive. Then when you rotate to quadrant 2, you think about the S in students, and that means sine's positive and cosine and tangent are negative. And then if we rotate to the 3rd quadrant, we look at T, and so that means tangent is positive, but sine and cosine are both negative. And then finally, the C in calculus is for the 4th quadrant, so cosine is positive and sine and tangent are negative. And that should make sense because I don't necessarily use this acronym, but I just remember that Y values are positive in quadrants 1 and 2. X values are positive in quadrants 1 and 4. And that's how I do it. But if this acronym or mnemonic device helps you remember, then go for it. All right, one other trick I want to show you, how to remember sine and cosine of the common angles. So basically angles in the first quadrant, including 2 of the quadrantal angles. Because again, if you know sine and cosine in the first quadrant, you can figure out sine and cosine of any angle measure on the unit circle. So for sine, you go numerator in ascending order, and the denominator is always 2. So square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. So the numerator always increases, the denominator always stays 2. And then if you simplify, obviously square root of 0 over 2 would be 0. Square root of 1 over 2 is 1/2. You leave rad 2 over 2 and rad 3 over 2 because you can't simplify. And then for 90 degrees, rad 4 over 2 would be 2 over 2 or 1. Okay. And then cosine is just the reverse. You start with rad 4 over 2, and then you descend the numerator, keeping the denominator always at 2. And so this obviously simplifies to 1. Rad 3 over 2, we're going to leave. Rad 2 over 2, we're going to leave. This simplifies to 1/2, and this simplifies to 0. And that's just a quick way to know the sine and cosine of all the angle measures in the first quadrant. All right, so let's see if we can put all this together. Evaluate the 6 trig functions at each real number. We're only going to do this for A. But I'm a real visual person, so I like to just make a quick sketch. And I know if I rotate 2 pi over 3 radians, it puts me in the second quadrant. And so if this is 2 pi over 3 radians, and I think of pi as 3 pi over 3, I know that my reference angle right here is pi over 3, which is the same thing as 60 degrees. So if I want to find the sine of 2 pi over 3, my reference angle is pi over 3 or 60 degrees. And I know either from knowing the first quadrant or knowing this that sine of 60 degrees is rad 3 over 2. I'm in the second quadrant, so sine is positive. Cosine of 2 pi over 3 would then be 1/2. And then tangent of 2 pi over 3, and let me jump back because I almost did what I see students do all the time. I am in the second quadrant, and so cosine, the x value is negative. So then for tangent, if I do sine over cosine or y over x, I would get negative rad 3. Okay, so now when we go to do the other 3 trig functions, the reciprocal trig functions, so cosecant, secant, and cotangent, we are just going to flip the ratios that we got for sine, cosine, and tangent. So sine and cosecant are reciprocal trig functions, so it would be 2 over rad 3. Then we have to rationalize, and so we get 2 rad 3 over 3. Cosine and secant are reciprocal trig functions, so this one's easy. The reciprocal of negative 1/2 is negative 2. And then tangent and cotangent, if I find the reciprocal of negative rad 3, it'd be negative 1 over rad 3, and then we have to rationalize, and we get negative rad 3 over 3. And all it took for me to do this problem was to find my reference angle, know what the sine of that reference angle is, and then think about the SIGNS, the sines of x and y in the second quadrant. Okay, find the exact values of the 6 trig functions of theta, and they give us a picture of theta with the following diagram. And this point right here is -4, +3. So we went 4 units to the left, and I don't think it really matters. Technically, the length of that horizontal leg of the right triangle is 4, but the negative tells us direction and tells us what quadrant we're in. We're not on the unit circle here. If I want to find the sine of theta, it's y/r or opposite over hypotenuse, and we don't have the hypotenuse, but if we know any two sides of a right triangle, we can find the third by Pythagorean theorem, and you ought to know that 3, 4, 5 is a Pythagorean triple. So now if I do opposite over hypotenuse or y/r, I would get 3/5. Cosine is then adjacent over hypotenuse or x/r, so that would be -4/5. And then tangent by either using opposite over adjacent or y/x, we get 3/-4 or -3/4. And then again, the reciprocal trig functions here are going to be very easy because once you know sine, cosine, and tangent, then it's real easy to just flip the ratios. So cosecant and sine are reciprocals, so that'd be 5/3. Secant would be 5/-4, and then cotangent would be -4/3. Okay, so if you're asked to find a trig function of an angle measure that is not a multiple of 30 or 45 degrees, or pi/6, pi/4 radians, you want to make sure your calculator's in the correct mode. So if you were asked to find the sine of 217 degrees, 217 is not a multiple of 30 or 45 degrees. So since the angle measure is given to you in degrees, you would want to be in degree mode. And then you can just punch it into your calculator. If you were asked to find the tangent of 3.24, there's no degree symbol, so that 3.24 is radians. So you would want to make sure you change to radian mode, which can be found under settings. And I believe in the top right corner of your calculator with this new operating system, it will tell you what mode you're in. It'll say DEG or RAD. So just be careful. That should be easy, but make sure you're in the correct mode. Okay, one or two more examples. If theta is an acute angle and we know the cosine of that angle is 0.8, and it says it's an acute angle. So acute means we're somewhere between 0 and 90 degrees. So I'm just going to make a quick sketch of theta somewhere in the first quadrant. And I know the cosine of that angle equals 0.8. Well, another way to think of 0.8 is 8/10 or 4/5. And if I think of it that way, it's really going to help me because I know cosine is x/r or adjacent over hypotenuse. So I know I can label in my triangle the adjacent side 4 and the hypotenuse 5. And then using Pythagorean theorem, I know the other side of the triangle is 3. And so now if I want to find the sine of theta, it would be 3/5 opposite over hypotenuse, or looking at the ordered pair, this would be the ordered pair 4, 3. It's not a unit circle if the radius or the hypotenuse is 5. So you just have to remember y/r. And then tangent of theta is obviously going to be opposite over adjacent. So that would be 3/4. Okay, last example. How would you solve the following equation? Really what you're doing here is working backwards. Okay, instead of being given the angle measure and asked to find the ratio of the sides, you are given the ratio of the sides and asked to find the angle measure. Well, if this equation were sine of theta equals 1/2, you know that theta would have to be 30 degrees. But the fact that it's negative means we are either in the third or the fourth quadrant, because those are the two quadrants where sine is negative. And since I know sine of 1/2, or excuse me, sine of 30 equals 1/2, I know my reference angle in both quadrants would need to be 30 degrees. So if I look to find the angle measure, this would have to be 210, and this would have to be 330. So those would be the two values of theta that work for this problem. So finish up worksheet